Hey guys. I don't know if you guys can hear me. Okay, hey guys. You guys can hear me. This is the new sheet that I did put up. Sorry, I'm about a minute late. This is the new sheet I did go ahead and put up on the Google Classroom. So, can you guys hear me? So, let's go. This is ratings, right? This is a topic on the unit circle, right? Again, ratings delves a little bit into geometry, but it is also its own subject within the unit circle. And some questions may come up on the ratings that you guys will have to take next year. So just looking at this, let's just start off by defining what are the terms we need to define, meaning the angle, as well as the arc length, as well as the radius. So I'm just going to read it from the beginning. I'm sure all of you guys can. Just as distance can be measured in inches, feet, miles, centimeters, etc., rotations about a point can also be measured in many different ways. Measuring one complete rotation in terms of 360 degrees is somewhat arbitrary. A common unit of angle measurement that is an alternative to degrees is called the radian. You first saw this unit of an angle in Common Core geometry. It is natural to define it in terms of geometry of a circle, given the unit we are in. The definition of radian, right? The radian angle theta created by rotation about a point A, right? Using a radius r and passing through an arc length of s is defined as theta equaling s over r, or equivalently, s is equal to theta times r. So in this sheet right here, so we're gonna start this off again, guys. You should be able to pick up the sheet from the assignments. I think this is due on Tuesday. Might just do this first page for you guys and have you guys do the second page, and then we'll go over it again on Tuesday. But okay, so now it says exercise 1. Consider a full rotation about a point around any point in the counterclockwise positive direction. So A says, what is the arc length S in terms of the radius of the circle? So they want to know what S is. Circle R for full rotation. So it was defined for us above. S equals theta times R. So B says, based on the definition above and on your answer to part A, how many radians are there in one full rotation? So one full rotation, the number of radians are 2 pi. One full rotation is going to be 2 pi radians. Keep in mind the radians are measured in pi. Give me 1 second. Give me 1 second, guys. Right? I just need to check on something in the backdrop. Hold on. Sorry guys, I'm back. Okay. Sorry guys, I'm back. In any regard, so let's look at X. Let's keep reading. It says radians essentially measure the total number of radii. Hence the name. That have been traversed traversed about the circumference of a circle in a given rotation, based on the circumference formula of a circle. Thus, there will always be 2 pi radians in one full rotation. All right. Well, let's just answer what previous questions said. So now, it says determine, exercise 2 says determine the number of radians that the minute hand of a clock, all right? So let's do this right here. Give ourselves a little clock right here. The minute hand of a clock passes through if it has a length of, so we have the hour hand right here, and we have the minute hand, right? So this is the minute hand. Minute hand. Passes through if it has a length of 5 inches, right? So this is the 5 inches right here, right? And travels a total distance of 13 inches. So essentially, say it went from here. I'm gonna reach this. Let's see. So this is the minute hand, the original. Right? So it traveled this distance right here, right? Which was 13 inches. And this is 5 inches, right? If we want to be able to find the number of radians, all right, so I'm sorry. Just look at this, right, guys? And we'll see how I'm getting this, right? Theta is going to be equal to 13 over 5. 13 being the arc length S. So remember theta, the formula says theta is equal to S over R. In this case, theta is going to be equal to 13 over 5. 5 is the radius, right? This is the radius, right? So I'm going to put radius right here. Radius. So then from there, we can go about to get the angle. Right? So let me divide 13 by 5. .6. So the angle is 2.6. So theta equals 2.6, which is the angle, right? They want us to determine the number of radians, right? So to get from angles to radians is remember the 180 clause. I think we did it before when we converted from angles to radian measurements. So 2.6 times pi over 180. (2.6 pi over 180). Everyone see how I got that? There's a horrible delay here, guys. So I'm a little bit ahead of what I'm hearing in the conversation, so I'm gonna keep going on. Otherwise, there'll be a long delay in instruction. I don't want that. So let's go right here. Let me erase this part right here. So if a pendulum swings through an angle of 0.55 radians, what distance does its tip travel if it has a length of 8 feet? So a pendulum, right? Let me erase this right here. So I'm going to draw a little pendulum right here. Through an angle of 0.5. So it's 0.55 radians. So it's, I'm just saying hypothetically. Tell me this angle right here is 0.55 radians. Essentially that, right? So in this case, they're giving me they give me the conversion. So it says if a pendulum swings at a point, what is the distance? So they're telling me that the radius right here is equal to 8 feet. What is it? So they want you to find S. So S is going to equal to times sometimes 8, right? But remember, I got to convert the radians back to an angle. So it's 0.55 radians, right? So it's 0.55 times 0.55 times pi right? So it's 0.55 times 180 over pi, right? That will give me the angle, right? So it's 0.55, right? So I'm going to multiply that. It's 0.55 times 180. So we're looking at 99. And remember, we want to convert this back to, what is the total distance? The distance would probably be in feet. Yeah, since they're using feet here. Okay. Keep in mind that the arc length, right, could be extremely big. is not bounded by just 360. That's dealing with the angle. All right, so come on, calculator here. Come on, let's just work. Oh, come on, what is this? This is 89 times 8. 792. Yep, that's the total arc length that was covered by this. The backside we'll do afterwards, guys. You guys have any questions on this? Please let me know. Any questions on this so far? I want to see how I got it. I want to see how I got these values. Let me know. Wait, let me double check something here, guys. All right. Actually, this is a better way of looking at this, guys. All right, which I think may lead to different results. All right, I was just looking at it right now, thinking about it. You have to consider this is a pendulum, right? So it's swinging back and forth. So it's first it swings at an angle of 0.55 one way, but then when it swings back, it's also 0.55. So a full swing would just be double that. So we're looking at 0.55 plus 0.55, right? 0.55 plus 0.55, right? Leaving us 1.1. We get 1.1, right? We're gonna get off right after this, two guys. All right. 1.1. Then we do have to take into consideration the total circumference of the circle, which is c is equal to 2 pi r. Right? So no, actually, Actually, no. Guys, hold on for B, all right? Hold off on B. Hold off on question B, all right? Let me just get back to you guys with that on Tuesday, right? Because I know it's going to create a lot of confusion. There's no other questions, guys. We'll see you guys on Tuesday. Ask me any questions you have. Leave it in the comment section, or just hit me up on the Google Classroom. All right? All right, so with that, guys, I'm going to end the session. Yes, yeah, okay, Amy, yeah, hold off on B. Hold off on B, because right now it says, yeah, it's actually saying an angle of, yeah. Yeah, you would have to convert the angle, you would have to convert that to angle of 0.55 radians. Yeah, it's 0.55. Right here, real fast. So it's 0.55 it's 0.55 radians. So it's 0.55 pi. You still have to convert that back, which is what we did initially. Yeah, you would have to convert that back. Yeah. Let me get back to you guys on that, right? So I'm going to end this. And then we'll go over it again on Tuesday. All right?